Morning, welcome to the next session. Now today we are going to learn about the another applications of the natural language processing NLP. One is a chatbot and another is a computer vision. So as we know, chatbots are basically a query based system, or they try to give the answer to a prescribed set of questions. So it is another applications of our natural language processing for a human communication. So we say pinnacle of practical NLP is the creation of a dialogue system or a chatbot. Chatbot means chatting robot. A chatbot can be used to automate common scenarios at IT support department and all the call centers. So if I have a call center where I want to find out some information, the person is not available 24/7, but the chatbot will be available 24/7, and that bot will be able to reply your queries. However, creating a bot that can reliably and consistently solve a task is not an easy one. So what we do is, client tends to communicate with the bot in other unexpected way. So the whole problem in the world is people try to become over smart and ask the chatbot to give a answer which is a stupid question sometime, or may not be a unexpected question. So it may behave in a unexpected ways. So you will have to have a lot of corner cases to cover the chatbot. NLP research is not quite at the point of providing a end to end. So we do not know what a user has in mind to ask the question. So sometimes the chatbot is not capable of answering the question. So that is limitation of the chatbot. So example I have shown here. Okay, so the chatbot is replying you, hello, how can I help you? So a automated system based upon the NLP, very popular now, is a chatbot where it can go and try to give the answer. Now let us look at the how a chatbot works inside as a software or as a data science, and how do we work in a chatbot engine. So general chatbot use several models to understand the user request and prepare an answer. So what the user is asking, I have to look for, query the user, and then prepare an answer. So the input is intent classification. So what user is intending to ask. So first thing is about this thing is your intent classification. After intent is clear, it goes to the entity recognition, and after entity recognition, it goes to a response generator. The response generator in turn talks to a already predefined database, and from there it will query the response and give the output. So this is just a scenario of a chatbot. Very simple, very easy to understand. So I have a intent, I have a entity, I have a response, and I have a output. So the intent classification model determines the user request. Entity recognition model extracts all named entities from the user message. The response generator model here takes the input from the intent classification and entity recognition model and generate a response. The response generator can also use a knowledge base which is based upon the database to look for the information to enrich the response. Sometimes the response generator create several number of responses. So it's possible that I can create multiple number of responses depending upon the type of the question you asked or you have been able to generate. So then a separate response ranking model select the most appropriate. So when I am selecting more than one number of answer, so which is the answer best suiting to the requirement of the questionnaire. So we go for a term called a separate response ranking. So I have another built-in model which will rank the most appropriate answer depending upon the type of the question. So this is how a internal of a chatbot works. Okay, so you can see here I have a user make a request, it goes to the chatbot uses its own internal brain, request analyzed by the artificial intelligence, user information is taken into account like what is the history, and this is another useful information for our ChatGPT 2. So is a history preferences, all those information are being stored into the database, and finally a real time response, conversation strategy, interaction, personalization, everything is given as a output. So this is another applications of our natural language processing to the human being. Now going further on from here, okay, NLP models can also generate text of arbitrary length based upon the initial input. So state of the model are available, and you can look at the, if you are interested, you can look at the ChatGPT 1 and 2 Okay, we have ChatGPT 2 model, 3, 3.5 and 4 is the recent one. So, this is the details of our ChatGPT. I have given the website and you can also look for the more details about the ChatGPT. Now, coming to the next applications of our what you call DS data science, we have computer vision. So, computer vision has taken the data science and deep learning by a storm. The reason is I am able to find out the answer where I was looking for a millions of the pictures. So, in 2010 the first ImageNet large scale visual recognition challenge was held. The task was to create a classification model that solved the ambiguous task of recognizing an object in an image. So, in total around 22,000 number of categories are to be chosen from. So, the data set is very enormous, contain over 14 million labeled images. Now, imagine you have 14 million images and you have to categorize them into one of the 22,000 classes or categories. So, for a human being is an impossible task or a very Herculean task, very difficult to do that, but ImageNet was able to do that. Okay, I mean people were able to do that using the deep learning method. If someone said and chose the top 5 objects of the each image would require a error of around 100. So, you can see the images having classification like mammal, placental, carnivorous, canine, dog, working dog, horse, Timran, sailboat, all those are. So many number of classifications are there. Now, for a human being is very difficult to comprehend. And in 2015 a deep neural network surpassed the human performance in ImageNet. Since then many computer vision algorithms have been entered. Now, I am showing you two more pictures here. One is called as image segmentation. So, suppose I have been given a image and I want to identify which and where is each object. So, object detection model recognizes object and place the bounding box around them. So, I have a car, my software will put a bounding box around it, but I have a car, another car like that. I have a object detection model where the model places a bounding box around the object. So, I have car number 1, 2, 3, 4, 5, so many objects are being detected by the software. So, this kind of scenario are very good for the surveillance purposes. This kind of software is very good for the people moving around in the road and accident prevention and things like that. Another applications of our what we call as a recurrent neural network or deep learning is instance segmentation model to find out the exact position of the object. So, I can find out from the model itself exact position of where the car is. This is used by the Google to identify a particular object. So, you can see the traffic light, you can see the car, you can see the every detail of the object is being visible on the screen, and so is on the computer too. So, these are another applications of our deep neural network. So, thus the main practical use of deep learning in computer vision are essentially the same as different level of resolution. We have image classification, determine the class of an image from a predetermined set of categories, object detection, finding a bounding box around a car or any other object, okay, which is inside an image, and assign a class which is most probable for each of the bounding box. Then we have image instance segmentation, doing a pixel wise segmentation of an image, outlining every object from a predetermined class set. So, handwriting recognition, face recognition, robotics, self-driving car, these are some of the applications of our computer vision. Okay, and this is another where a artifact is being generated by the computer as a artistic painting design. So, you can see that another good applications of the computer vision is this way. Okay, and some of the generative adversarial GAN generative adversarial network are creating image of a person or a face or any animal where the person or face or animal is not existing in the world. So, you can see that GAN has generated so many number of different pictures, and it can be used for animation, it can be used in the film industry, it can be used for any of the other good constructive purpose. So, this is another applications of our GAN. Okay. So, we can also use GAN to perform conditional image generation. The word conditional means that we can specify some parameter for a generator. So, it is another area of research, and a lot of people have done the good work on that one. In fact, NVIDIA has generated a lot of software that can transform a simple color coded image into a different a type of object, like representing a soil, representing a sky, water and other kind of object to a realistic photo. Okay. With this I end here, and thank you so much.